Hello, welcome to Topic 4, Chemical Bonding and Structure. When learning about chemistry, it is important to understand the chemical bonding and structural arrangements of compounds. Chemical bonds are in charge of holding all the atoms in a molecule or ions in an ionic compound together. In this topic, we are going to learn about three main types of bondings: ionic bonding, covalent bonding, and metallic bonding. Then, we are going to explore the differences in structure between the ionic and covalent compounds. This topic is composed of 5 subtopics. In subtopic 1, we are going to learn about the bond and structure of an ionic compound. In subtopic 2, we are going to explore the bonds involved in a covalent compound. And in subtopic 3, we are going to learn about its structure. Next, chemical principles such as intermolecular forces will be explained in subtopic 4. And lastly, we're going to learn about the metallic bonds in subtopic 5. Let's begin with the first subtopic, ionic bonding and structure. Words that are highlighted in yellow are important vocabs that IB wants everyone to learn. These vocabs might be tested on your paper 1 as a multiple choice question, or they might be tested on your paper 2. And IB will directly ask you to define these words. As I mentioned in my previous videos, please learn them, memorize them. We're going to go over some key vocabs before jumping into the topic. You might already know some of the terms from previous topics. First, cations are positive ions and they are formed by metals losing valence electrons. Anions are negative ions and they are formed by nonmetals gaining electrons. Ionic bonds are bonds formed by the electrostatic attraction between oppositely charged ions. The key phrase in this definition is oppositely charged ions, as the attraction between positive and negative charges creates an ionic bond. In addition, ionic bonds form when electrons are transferred from one atom to another to form ions with complete outer shells of electron. Another key phrase here is the word transfer, as it explains how the positive and negative ions cling together. Next, polyatomic ions. Polyatomic ions are ions containing more than one element. Common examples of polyatomic ions are ammonium, hydroxide, nitrate, hydrogen carbonate, carbonate, sulfate, and phosphate. You should know how to read and identify these polyatomic ions. Now, let's look into ionic bonding. As I mentioned in the previous slide, ionic compounds are formed when electrons are transferred from one atom to another. To achieve noble gas configuration and become more stable, atoms combine, and this completes their outer shell of electrons. Looking at the image right here, you can see that the sodium atom has 1 valence electron and chlorine atom has 7 valence electrons. As the sodium atom transfers its outer electron to chlorine, the sodium atom becomes a cation and the chlorine atom becomes an anion. These two oppositely charged ions now have achieved a noble gas configuration and they attract each other to become an ionic compound. Under normal conditions, ionic compounds are usually solids with strong lattice structures. As you can see right here, the sodium and chlorine ions build up into a strong lattice structure of sodium chloride. Because a lot of energy is needed to overcome the electrostatic attraction, ionic compounds have high melting and boiling points. Also, ionic compounds have low volatility, which means that they have a low tendency to vaporize. And this is because of their strong electrostatic forces. Ionic compounds are also soluble in polar solvents like water. And solid ionic compounds are unable to conduct electricity, while molten ionic compounds are able to conduct electricity because the ions are free to move in the molten state. Let's look at some ionic compounds. For IB, you should be able to deduce the formulas and names of ionic compounds from its component ions, including polyatomic ions. On the left-hand side, I have listed some names of ionic compounds, and on the right-hand side, I have listed some formulas of ionic compounds. Let's try to find the formulas and names of all the ionic compounds above. We can see that all of these ionic compounds is made up of a combination of a metal and nonmetal. The first one, potassium chloride, is made up of a potassium ion from a metal and a chloride ion from a nonmetal. By looking at the periodic table, we know that the potassium atom has 1 valence electron and a chlorine atom has 7 valence electrons. So, to achieve a full octet, the valence electron of potassium will be transferred to chlorine. The potassium atom will now become a cation that has lost 1 electron, and the chlorine atom will now become an anion with an additional electron. To write the proper formula of potassium chloride, the charges will cross-land on the other side. If the numbers on the side are a multiple of each other, they will cancel out. In this case, the numbers 1 will cancel out and simplify to KCl. This is the formula for potassium chloride. Now, how about number 2, chromium 2 fluoride? First, we know that chromium is a transition metal. But how many electrons have been transferred from the transition metal chromium to the nonmetal fluorine? The number right here gives us a hint. This number shows how many electrons have been transferred from the metal to the nonmetal. In this case, chromium has lost 2 electrons, so will become a cation with a charge of 2+. However, to make a full octet, 1 fluorine only needs 1 electron. So the fluorine atom will become an anion with a charge of -1. But since the chromium has transferred 2 electrons, and the ionic compound only involves chromium and fluorine, we know that the chromium has transferred its second electron to another fluorine atom. This can be shown when we cross-land the charges of chromium and fluoride ions. We can see that 1 chromium ion has bonded to 2 fluoride ions, and this is the formula of chromium 2 fluoride. Third question, lead 4 nitrate. Now, a transition metal is bonded to a polyatomic ion, nitrate. We know that the lead atom will become a cation with a charge of 4+. And previously, I have already shown you that the overall charge of the nitrate ion is -1. By cross-landing the charges, we get Pb parentheses NO3 4. And we can see that 1 lead ion is bonded to 4 nitrate ions. Don't forget the parentheses as it separates the lead ion from the nitrate ion. Now, let's try naming the ionic compounds. This is a bit more easier. Question number 4. By looking at the compound, we can see that 1 magnesium ion is bonded to 2 bromide ions. And we can easily name this compound as magnesium bromide. Question number 5. Looking at the compound, we can see that 2 iron ions is bonded to 3 oxide ions. So many of you might just name the compound as iron oxide. However, this is wrong. Because iron is a transition metal, we need to clearly state how many electrons have been transferred to the 3 oxide ions. How can we do this? Instead of cross-landing the numbers, now let's cross-fly them upwards. We can see that the iron ion has a charge of 3+, and the oxide ion has a charge of 2-. We can see that 3 electrons from the iron atom has been transferred to 3 oxygen atoms. So the name of this compound will be iron 3 oxide. Last question. I want you to stop the video and try this on your own. Okay, in this compound, lithium ions are bonded to a polyatomic ion, phosphate. So the name of this compound will be lithium phosphate. If you have any questions about this video, feel free to comment below. Okay, see you in the next video.